Hello students, now in class 11th, today I will take the reflection and refraction of the sound waves. So sound waves can be reflected, refracted, diffracted just like the electromagnetic waves. Reflection and refraction of sound waves. The sound waves can be reflected, refracted, and diffracted just like electromagnetic waves. Electromagnetic waves. So, and you know that the sound waves are the longitudinal and transverse, both kinds. So first I will take the reflection. Reflection of sound. The sound waves are longitudinal waves in gaseous medium and transverse waves in liquid and solids. There may be the longitudinal waves in liquid and solids also. There may be longitudinal waves in liquid and solids. The reflection of sound waves follows the laws of reflection. Just like reflection of electromagnetic waves. It means that the angle of incidence is equal to angle of reflection. The reflection of sound waves gives two phenomena. Number one, reverberation. And number two, echo. Reverberation and echo are also the cases of the reflection of the sound wave. Reverberation means the prolongation of the sound wave. When the same sound wave is heard for a long time, then it is called the reverberation. And this reverberation takes place whenever the two objects are at a distance of 17 meters or less than this. A long sound can be heard. And this is may happen in the auditorium, the halls, cinema halls, and also at your home. So reverberation is a very common phenomenon, and in this, the case of reverberation, the time interval is 0.1 second. So if the wave is reflected and received by the listener in 0.1 second, then he will listen a long sound. This is called the reverberation. Echo is also the reflection from the obstacles, and in case of echo, if suppose sound is produced by some source and this is listened by some observer, and the wave also is reflected from some obstacle like the ball, building, and the hills, etc. Then, if the time of the sound heard, of the reflected sound that is received by the listener is more than 0.1 second, then he will listen again the same kind of sound. So the reflection of the sound wave from the different objects which are at a distance more than 17 meters or approximately equal to the 17 meters, and this is in the open space, then this echo takes place. So both of these phenomena is due to the reflection of the sound wave. If sound wave is reflected from denser medium, this suppose the wave is moving in the air and then it is reflected by the water surface, then this is water is the denser one. So from that, when this is reflected, then you know that in gases we are in the rarefaction and compression. So a reflected wave will have the same compressions and rarefactions. If suppose some compression is incident on the water surface, then this will reflect as a compression. So compression is backed as a compression and rarefaction as a rarefaction. And if it is the transverse wave, then it will be the troughs and crests. If trough is incident on the surface, then reflected we will have also the crest. So then rarefaction. Reflects as rarefaction. And compression. Reflected as compression. Compression. And also in case of transverse wave, crest is reflected as crest and trough is reflected as trough. So what's the incident? There is no phase change between incident wave and reflected wave. This is only when the sound is reflected from the denser medium. So incident wave y equal to a sin omega t minus kx, and the reflected wave y equal to a sin omega t plus kx. Because the going light, this is suppose going from in the positive direction of x-axis, then we are having this equation. When this is reflected, then this will move in the negative direction of x-axis. So this will now y equal to a sin omega t plus kx. There is no phase change at all. Or we can say that the incident wave and the reflected wave are in the same phase. The reflected sound wave and incident sound wave are in same phase. In same phase. So here the phase same phase means this is now your 2 pi, 4 pi, 6 pi and so on. So this is equal to 2 pi n. Here where n equal to 1, 2, 2, 3, 4, 5, the natural numbers. So same phase, meaning same phase means that it is the phase difference of 2 pi, 4 pi, 6 pi. This is also called that there is no the phase difference between the incident and the reflected ray. So this is from the denser medium. If sound wave is reflected from rigid medium, what happens that in case of denser medium there is the vibrations in the particle, and in case of the rigid medium this the vibrations are approximately zero. So what happens that if suppose some longitudinal wave is being incident, suppose there is the trough that is there is the compression that is being reflected as a rarefaction, and rarefaction is reflected as a compression. The compression is reflected as rarefaction, and rarefaction is reflected as compression in case of longitudinal wave, and that in case of transverse wave, the crest is reflected as trough, and that trough is reflected as crest. This is in case of rigid medium. Suppose over here I am having this the rigid medium, and this is the trough. This is a crest moving towards this one, and when this will be reflected, then there will be like this. So this is not reflected, and in this case there is a phase change of pi radians. The reflected wave and incident wave. Have a phase difference of pi radii or 180 degree. It means that both the waves are in. It means both the waves are in opposite phase. Opposite phase. So now what we have, incident wave. Incident wave y equal to a sin omega t minus kx. Reflected y equal to a sin omega t plus kx plus pi. Plus kx because this will reflect in the opposite direction, and this the phase difference of pi. So this y is equal to minus a sin omega t plus kx. This is the equation of the reflected wave. So we can say that the incident and reflected wave are in opposite phase and having phase difference of pi, 3 pi, 5 pi, 7 pi, the odd multiple of pi. So this is what the reflection of the sound wave from the rigid medium. And now we take the refraction of sound waves. Refraction of sound waves. The sound waves are also reflected just like the electromagnetic waves, but this reflection of sound wave does not obey the law of reflection, just in case of electromagnetic waves. When a sound wave goes from one medium to another medium, at the boundary, at the interface, the velocity and wavelength both change, but frequency remains constant. So if suppose the refraction and direction of reflected ray. Is different from that of incident. The direction of refracted wave is different from that of incident wave. So now you can have, let's suppose this is the interface, this is not denser medium, and here is suppose a wave. This is the normal, then this will go like this. So it will deviate away from the normal ON and NS. This is the angle of incidence I, this is the angle of refraction R. This suppose the velocity is equal to v1 and here the velocity is equal to v2. Then this is the rare medium. And this is denser medium. The refraction of sound wave does not follow the laws of refraction just like the electromagnetic wave. The refraction of electromagnetic wave. If suppose we are having the velocity v1 in the rare medium, then this is not velocity in the denser medium, then the velocity in denser medium v2 is greater than v1. And here refraction from rare medium to denser medium. The angle of incidence is less than the angle of refraction. This means that this I is less than R. So the velocity, if we have this sin I upon sin R. Then no, meaning that this is equal to B1 upon B2 and this is equal to lambda 1 upon lambda 2, as B1 equal to n lambda 1, B2 equal to n lambda 2. There is no change in the frequency. So this is what we have, this sin I upon sin R. But this is not equal to the refractive index. It means that the ratio of sin I upon sin R or B1 upon B2 does not represent the refractive index of the medium. Though this ratio remains the constant, but this is not the refractive index, because you can see from here that this B1 is less than B2. Since B1 is less than B2, so sin I upon sin R is less than 1, which is not possible, because in case of this is a denser medium, this being a rare medium, definitely the refractive index must be greater than 1. But here we are getting that this is less than 1. It means that this ratio does not represent the refractive index of the medium. The ratio sin I upon sin R does not represent the refractive index of medium, though it remains constant. This ratio will remain constant, but this is not the refractive index of the medium. And moreover, the refracted and the incident wave are in the same phase, so there is no phase difference at all. The refracted sound wave and incident sound wave have no phase difference. This means that they are in the same phase. It means they are in same phase. This is what the reflection from rare to denser. Now if we take the opposite to this one, refraction from denser to rare medium. Then this happens just opposite, that the angle of incidence will be more than the angle of refraction. So what we have, the angle of incidence is more than angle of refraction. angle of refraction. It means that angle I is greater than angle R. So sin I upon sin R, this is again equal to B1 upon B2. Now this is suppose the denser medium and the wave is going like this. This is the angle of incidence I. Then this is the angle of refraction. It means that the refracted ray bend towards the normal, and in case of from rare to denser, the refracted ray bends away from the normal. So here this the speed is suppose B1, this is now your B2, and this is equal to your lambda 1 upon lambda 2, and even this is not equal to the refractive index. Refractive index of medium. So this is what about the reflection and the refraction of the sound waves. Sometimes the questions are asked from this one. So I can write the equation. Incident ray y equal to a sin omega t minus kx, and refracted y equal to a sin, this is now your omega dash t minus kx. So this will be in the same direction. This is moving in the same direction. So the direction is not being changed, but this angular frequency will change. This is now omega dash. Or we can write it to more better is y equal to a sin 2 pi upon lambda 1 into b1 t minus x, and this is now your y is equal to a sin 2 pi upon lambda 2 into b2 t minus x. We can write it like this one. Because lambda 1 and b1 will change, but the frequency will not change at all. So this is what the incident and the refracted ray. And now I am going to tell you one more thing, that online classes from June 1st, 2021, and it is now your 11th, 12th, and that NEET. In NEET we are having two things here, that is crash course this is 2021, and regular class 2022. Contact 70147, and this is now your 34805. This is your contact number. So you all like, share and subscribe this video. Thank you very much.